In this video, we will continue to practice using our notation of probability and doing our probability calculations. But then at some point, okay, right around problem number 4, I'm going to introduce something called conditional probability. That's where you're being asked to calculate the probability of something given a certain piece of information is already known. So we've got this Venn diagram, and it looks like the first row of the chart has already been filled out for us as an example. So this notation means we've got the intersection of A and the complement of B. In other words, A and not B. And of course, the P in front means the probability that this is happening. So the probability that it is in A and not in B. So then we have that shaded, showing the region that is in A and not in B. Now they did this calculation 6 out of 20, of course, because the 6 is how many is in that event, and 20 is going to be the total. If I add all 4 of these numbers together, that's the 20. And it reduces down to 3 over 10. And just for fun, I usually like to write these probabilities as fractions and decimals and percents. So this would be the same thing as 0.3, 0.3, which would equal 30%. Okay, so I'm going to tend to put all 3 forms. Okay, now let's do the rest. So for problem number 1, we're given the shading. So what is this? Okay, so this is a shading of A or B, because I see that all of circle A, all of circle B is shaded. So this is going to be A or B, which would be written like this: A union B. Alright, so we're going to talk about the probability of that. Okay, so that's the probability that it is in A or B. Okay, now let's do the calculation. So the probability of being in A or B, we already decided that these are the numbers in A or B. So when we do probability, we're doing target over total. So that's the target I just highlighted. That's going to be 17. So that's 17 out of a total of 20. So that's one way of writing it. So let me switch over. Okay, so we have 17 out of 20. So as a decimal, 17 divided by 20, that's 0.85. So that's the decimal form, which if we move the decimal point twice, gives us 85%. Okay, now let's take a look at what is next. For problem number 2, we have the probability of A or not B. A or not B. Okay, so let's do the shading of that. Alright, so I want the probability of A or not B, the complement of B. Okay, so when we're doing union, and I'm saying or like this, we're going to shade everything that's mentioned. So we're going to shade all of A, because A is mentioned. and then we're going to shade not B. So not B is everything that is outside of B. So that's going to be all of this.
Love it.
So this is what A or not B would look like shading wise. So now as far as the probability, that's going to be target over total. So the target is everything that we shaded, so which is 13, out of the total, which was 20. So that's one form of the answer. As a decimal, we're talking about 13 divided by 20. So that's 0.65. Another form of the answer, moving the decimal point twice would give us 65%. So that's another form of the probability. So just to review that answer, these symbols mean the probability that it is in A or not in B. And the shading looked like this. And these were the probabilities that we calculated. Okay, so let's switch over and take a look at number 13. So having a little line over it is another way of showing the complement. So this is another way to mean the probability of not being in the set A union B. So we're talking about the probability that it is not in A or B. Okay, so basically these two things mean the same. So where is the space that is not A or B? So we're talking about everything that is going to be outside of A or B. Okay, so if we look at everything that's outside of A or B, we're talking about in this region out here. So you can pretty quickly see that there's only one number out here, and that is the number 3. Just going to do a little bit more coloring real quick. Alright, you get the idea. So this is the region that is not in A or B. So as far as calculating the probability, target over total. The target is this 3 out of a total of 20. And then as a decimal, that's going to be 3 divided by 20. So that's 0.15 or 15%. So just to review that answer, we have the probability of not being in A or B, alright, which I wrote in words right there. The shading would look like this, and the probability calculations would be like this. Okay, so let's jump over to problem number 4. This time we're given the words, the probability that it is not in A, given that it is in B. So first of all, this is going to be a new notation for us. So the probability of not being in A, that part is normal. Alright, so this would be the probability of not A. Now when you're given some additional information, you put a vertical line and then you put the additional information. So this would be the probability of not A given that it is in B. So that's how the notation works. Now, what does that mean in terms of our shading? Okay, let's start over. when you're given this additional information, I suggest you focus on that first. Okay, so we are given that it is in B. That extra information shrinks down the universe to just B, because we were given that it is in B. So normally we have this entire rectangle is the universe when we're doing target over total and all that. But when they give you some additional information, you should think of it as shrinking the universe. Alright, so if we're given that it is in B, then that means everything outside of B is gone. Alright, so I'm just going to black out everything that is outside of B, because this is the new universe. The universe where B is all that exists. Alright, we are given B, so B becomes the new universe. Now, I'm about to black this out, so we'll just remember that the 4 was from A and the 7 was from B as I black the rest of this out. Okay, so this is a very dramatic way of showing what it means to be given B. Now remember, this portion of the graph was from B, and this portion of the graph was from A. So now that we've clearly shown the part that's given, now we can look back and look at the other part. So we're given that it is in B, but we now want to calculate the probability of not A. Okay, let's write that down. So we're trying to find now the probability of not A since we're given B. Okay, so just looking at the remaining part of the universe, if I want to calculate the probability of not A, alright, I'm doing target over total. So let's do what we always do. Let's shade in the part of this picture that is not A. Well, if this is A over here, then not A is going to be this part of the universe. Okay, so that's my target. So target over total, the target is 7 and the total is 11. Alright, because we were given B, we blacked out everything else, so you can forget about all those other numbers when we talk about the total. The total is just going to be 11. Okay, so that is the probability of not A given B. Of course, we can write this as a decimal and a percent by doing 7 divided by 11. Okay, so that's 0.63 repeating. So I'll say 0.6363 approximately, which is 63.63%. So quick summary of number 4. These symbols would mean the probability of not A given B. And here, that's what it looks like in words. The shading looks like this because the given B part blacks out everything except for B. And then we do the not A is then shaded. And here are the calculations, the target over total. Okay, for problem number 5, we are being asked to calculate the probability that it is not in B given that it is in A. So these symbols mean the same thing as these words. Probability of not B given A. Now, when you're given something, I want you to think of that as the new, smaller universe. So this is going to be the new, smaller universe. So the universe started out as being represented by the entire rectangle, but we are given A. So that's going to be the new, smaller universe. So I'm going to black out everything that is not A. Since A is given, A becomes the smaller universe. Okay, just focus your eyes on that. Black out everything else. Okay, so let's keep in the back of our minds that this part of the picture is A and this part of the picture is B. So now that we've blacked out everything except for A, that takes care of the given. So now we can focus on doing the calculation mentioned in the first part. So now we can just do the probability of not B. So let's start by shading in not B. So here's B over here where the 4 is. So not B is going to be over here where the A is. So here we're shading not B. So what's the probability of that? Well, target over total. The target is what we just shaded, the 6. The total is 10. Alright, be sure to ignore all that stuff we just blacked out. We're just looking at the new smaller universe, just the 6 and the 4. So to get our 3 answers, let's reduce this down to 3/5, which as a decimal is going to be 0.6. Because if we just do 3 divided by 5, that's 0.6. If you move the decimal twice, that will be 60%. For number 6, this notation would be read, the probability of B given A. That means the probability that it is in B given that it is in A. Okay, so again, I encourage you to focus on the given part first. Given that it is in A. That makes A the new, smaller universe. Okay, that's what given A means. So since A is the new smaller universe, we can black out everything outside of A. So just focus your eyes on A, because A is given. Forget about everything else. Nothing to see here, folks. Doesn't exist. Okay. So, once you've blacked out everything except for your new smaller universe A, then you can go ahead and calculate the probability that they are asking you for. Let's not forget that this portion of the graph is still A, and this portion of the graph is B. So we want the probability of B now. Okay, looking at our new smaller universe, what's the probability of B? Well, let's shade the target. So if we want the probability of B, then that means we should shade in B. Okay, so there is B. That's now shaded in. So the probability is target over total. So the target is the B that we just shaded. The total, well, looking at our new smaller universe, the total is 10. This reduces down to 2/5, which as a decimal is going to be 0.4, which means as a percent, that's going to be 40%. For problem number 7, we're given the picture. So can you see the new smaller universe? See all these black lines? They're showing that we're blacking out everything except for set B, circle B. So that means circle B must be the given, because that's the new smaller universe. So when we set up our notation, we're going to be talking about the probability of something, but we're definitely given B, the new smaller universe. Now, the thing that we're calculating the probability of has to be what is shaded. So what's shaded here is portion A. So we must be finding the probability of A given B. So whenever we calculate the probability, if we want the probability of A, then we're thinking target over total. So A is the target, so that's going to be 4 over the total, and the total here is 11. The smaller universe just has the 4 and the 7, that's it. Forget about any other numbers that you've seen. So the total is now 11. So we can figure out what the decimal version of that is by simply dividing 4 by 11. So that looks like 36.36 repeating. So I'll say 0.3637 approximately, which if I move the decimal point twice is 36.37%. The next several problems refer to this Venn diagram right here. Each one of these stars represents a person. I think it will be helpful to put some numbers to this. So in this region, I see that we have 6 stars, so I'm just going to go ahead and write a 6. And here we have 2 stars right here. We have 5 stars in this area over here. And outside in this outer area, we have another 5 stars. So, by the way, that is a total of 18. Okay, so if we want the probability of A and B, okay, so we're looking for the probability of A and B. So the target is the overlap in this case. All right, this is A and B. So that's 2. but we're doing probability, so we're not just going to say 2. We're going to do 2 divided by 18, target over total. Of course, that's going to reduce down to 1/9. So let's go ahead and turn that into a decimal as well. 1 divided by 9. So that's 0.1 repeating. Or 11.11%. Okay, so next we have the probability of A or B. Alright, this is a union. So if we do A or B, we're not talking about the overlapping part anymore. We're talking about everything. We're talking about all of A, all of B. So that would be what I just shaded. Okay, that's A or B. So if I want the probability of this, I'm not just going to say the number. I'm going to do target over total. So far, okay, that's 11, 12, 13. So what I've shaded is 13 out of a total of 18. Okay, so let's get the decimal form of that as well. 13 divided by 18. That's 72.7222. Which as a percent would be 72.22%. So these are the 3 versions of that probability. Okay. Next we want the probability of not A and B. Okay, so not A is everything that's outside of A. So we want to be inside of B, but not inside of A. Alright, so inside of B and not inside of A. So we're talking about this region right here. Okay, we're outside of A, so we've got the not A happening, but we're inside of B. Okay, so that's the target. So the probability is target over total. So for the target, that's 5. And still the total is going to be 18. Okay, so that's 0.277, and I'll round up to 8. Which as a percentage would be 27.78%. So those are the 3 forms of that probability. Okay, and finally, for this Venn diagram anyway, we have the probability of A given B. So the probability of A given B. So remember, we focus on the given part first, and we will think of that as a new, smaller universe. So we are given B, so that means we're going to black out everything except for B. Okay, so all of this is gone. Alright, now keep in the back of your mind that this portion is A and this portion is B. So now that we've blacked out everything except for the given, now we can focus our attention on the probability we're being asked to find, the probability of A. So we will highlight that as the target. So the probability of A, so here's A. Okay, so now let's calculate that probability. So we're going to do target over total. So the target, the A, is 2. The total is no longer 18 because we have this new smaller universe. So the new total is 7 because this universe just has the 2 and the 5. That's it. So target over total is now 2 out of 7. Okay, 2 divided by 7, that's 0.2857. Okay, which as a percent would be 28.57%. So those are the 3 ways of writing that probability. Okay. So for the next few problems, we're going to use this information. 80% of people can swim. 70% of people can whistle. 55% of people can do both. I think the best thing to do is to make a Venn diagram. So let's see. Some people can swim, some people can whistle, some people can do both. I think you know what I'm about to do. All right, this circle will represent the set of people who can swim, and this circle will represent the set of people who can whistle. So obviously this part in the middle will be the people who can do both. Since we are dealing with percentages, let's imagine that the total is 100, all right? 100 people. That way, instead of having to write the percent sign, I can just write 80 and 70 and 55. And it'll be understood that that is percent. So 80% of the people can swim. Actually, you should start with the overlapping part, always. 55% of the people can do both. So that means out of 100 people, 55 can do both, swim and whistle. So then when I talk about the 80% of the people that can swim, I'm not going to put 80 right here. That would be a big mistake, because that means I really have 80 plus 55% that can swim. That's like 135 people, 135%. Instead, we have to subtract that 55. So this is going to be 25, okay, because 25 plus 55 together, that makes the 80% of the people that can swim. We'll do the same thing with the people that can whistle. Okay, so we've already got the 55, so I think we want 15% in this zone over here, because if you add that up, that'll 55 and 15 add up to 70. So together, now we're showing 70% of the people whistling. Okay, but only 15 should be out here in this region. So let's see what's left over that needs to be in this outer zone. So right now we have 25 and 55 and 15. So let's see. If we do 100 minus the 25 minus the 55 minus 15, that leaves 5. So that means 5% of the people can neither swim nor whistle. Okay, what percentage of people can swim or whistle? Okay, well, swim or whistle, that means all of these people. All right, all of these people can swim or whistle. So that's going to be 95. All right, that's everybody except for the 5% of the people who can't do either. Okay, so 95%. Okay, what percentage of people can neither swim nor whistle? Well, that's that 5% out here, the people who can't swim or whistle. All right, so there's 5%. What is the probability that a person can swim given that he or she can whistle? These problems are fun to me because I like to shrink the universe. When you're given something, that given information shrinks down the universe to just that statement. So given that he or she can whistle, that tells us to shrink down the universe to just whistling. Okay, so given that he or she can whistle, that means the universe will shrink down to the whistling circle. Everything else is going to go away. Okay, so this is the new universe. Keep in mind that this part is still swimming and this part is still whistling. Now that we have shrunken the universe down to only this, now we can go ahead and calculate the probability that they're asking us for. What is the probability that a person can swim? Okay, so that's this part of the graph right here. These are the swimmers in the new smaller universe. These are the swimmers. Okay, so what's the probability that we just shaded in? Well, that's a target over total, so that's going to be 55 is the target. Now the total is no longer 100. The universe has shrunk to just the W, okay, which was 70. The 55 and the 15, that's 70. So 55 out of the 70, target over total. Okay, now let's reduce this. So let's divide both of these by 5. Okay, so 55 divided by 5, that's 11. Now what about 70 divided by 5? That's 14. Okay, now so this is the answer in fraction form. Now as a decimal, that's going to be 11 divided by 14, 0.7857. Which is 78.5 0.57%. So these are the three forms of the probability that a person can swim given that he or she can whistle. Okay, now what is the probability that a person can whistle given that he or she can swim? All right, well, give me a second to modify my Venn diagram. This time we are given that the person can swim. So I'm going to circle really darkly the swimming circle, and I'm going to cross out everything else. All right, because my universe is shrinking down to just the set of people that can swim, because we're given that they can swim. Now, remember that this portion of the circle came from the swimming, and this portion of the circle could also whistle. So now, what's the probability we were asked to find? What is the probability that a person can whistle given the shrunken universe? So the probability of whistling, all right, that makes the target is the whistlers. So we should shade that in. Now, probability is target over total. That's 55 over a total of 80. Okay, so that's 55. Over a total of 80. Notice one more time that the total is not 100 because the universe shrank down to just this circle of swimmers. Just the 25 and the 55, only the 80. So we do 55 over 80, not 55 out of 100. Okay, and again, both of these are going to be divisible by 5. So this is going to be 11 over something. Okay, 80 divided by 5, that's 16. Okay, and then 11/16 as a decimal is 0.6875. Which is the same as 68.75%. So those are the three forms of the probability that a person can whistle given that he or she can swim. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.